Chance and Data External Review video. We're going to chat about scatter plots, one of the graphs that's likely to come up in this year's exam. And we're going to look at an old example from 2021. It's not that old, it's last year. This graph has the number of registered dogs on the x-axis per council and the number of dog-related ACC claims, the number of injury claims from dogs. And notice the data was taken from the year 2019. Look at this example. This point here represents a council like perhaps the Porirua City Council that has nearly 10,000 dogs registered, and that year they had about 180 dog-related injury ACC claims. So scatter plots, what do? Well, they basically trying to figure out, is there a relationship or a correlation between these two variables? To do that, we need to look at the strength of the relationship. That's the first feature. And we could have a very weak relationship, data scattered everywhere. We could have a weak relationship. We could have a moderate relationship. We could have a moderately strong relationship. Or we could have a very strong relationship. What we like to do is draw an oval through the points, and then the narrower the oval is, the stronger the relationship is. To our 2021 example, I'm going to draw my oval. Now notice I've missed out a few points. That's not vital. But if I compare it back, this is a moderately strong relationship. So I'm going to say there appears to be a moderately strong relationship between the number of dogs registered in each council and the number of dog-related ACC claims during the year 2019. Now, we can draw a straight line through the middle of our oval, and we call this a line of best fit. We can use the line of best fit to estimate, and we often get questions in exams that say estimate something. So if you were asked to estimate how many claims were made for 15,000 dogs, you would draw a line at 15,000 and then race across the y-axis to say there would be about 390, just under 400 claims for 2019. Right, notice the line of best fit. As the number of registered dogs increase, the number of dog-related ACC claims also increases. This is what we call a positive gradient. And remember, gradient is rise over run. Now, for merit excellence, you may actually want to go and calculate the gradient of this line and work out the gradient for the number of dogs-related ACC claims for every dog registered. But if I was to look at an older exam, the 2015, which measured the memory test score against age, first of all, it's a pretty weak relationship. But also, as I add in my line of best fit, notice a negative gradient, which means as the age increased, the memory test score generally tends to decrease. Right, some other features we can talk about. Well, look at this. We have a cluster of councils down in this region, less than 10,000 dogs registered and under 200 claims. And not so many councils in this region, a little bit more sparse and quite a few gaps. Maybe there's some data missing and we might have to go and collect more data. Or we just may not have that data. There might not be that many councils in this region with that many dogs. If I go and put my oval back, actually we have 4 points missing, don't we? I talked about that earlier. I should have probably drawn my oval a bit better and included these three because they tend to follow the trend. But there is 1 point that definitely doesn't follow the trend. And we call this an outlier or an extreme value. And we could chat about why this is and what it could mean. Right, what else? Well, notice our line of best fit. Actually, can you notice there's a bit of a fan with the data? As the number of registered dogs increases, the number of dog-related claims seems to get more varied, more variable. And we could talk about why and what that means as well. And finally, if we go back and put our line of best fit, we always start with a linear line of best fit. Actually, I hope you can see that there's probably a better line of best fit, which is non-linear, a curve. And in this example, I'm calling it an exponential growth curve because it kind of starts off pretty level and then at about 10,000, it rapidly increases. All right, I hope that helped you with a few things. Thanks for watching.